Welcome to this particular video with Anakwa Christopher GK, your chemistry teacher, of course, and we have been following this series. In this particular video, we'll be introducing a very important part of chemistry. But before we start that, if you are watching this particular video class on YouTube, remember to subscribe to my channel if you have not done that. Hit the subscription button and you will be notified whenever I have new video uploaded in my channel. All right, let's have the topic of this particular class is Introduction to Hydrocarbons. Of course, we have treated a different part of chemistry before now, but this particular aspect is an organic aspect of chemistry, and we are going to introduce it with this topic, Introduction to Hydrocarbons. And it's expected by the end of this class or this particular video, you should be able to explain the meaning of hydrocarbon and the sources of hydrocarbons. You should be able to state the classification of hydrocarbons. You should be able to even discuss the crude oil and its formation. Then number 4 is that you should be able to list the fractions of crude oil. Next, the last but not the least is list the economic importance of the products of crude oil. These are the things we want to achieve in this particular class. So we are going to we'll take them one after the other. First of all, we'll start with hydrocarbon. What is it? Hydrocarbon. Of course, look at the word hydro and carbon. It's just a combination of two words. And the hydrocarbons means are compounds, of course, organic compounds that contains only hydrogen and carbon. Any compound, any organic compound or any compound that you see that contains only hydrogen and carbon in the molecule, we can call it hydrocarbons. All right, they are simple organic compounds with the molecular formula CXHY. CXHY means that they contain some atoms of hydrogen, carbon atom and hydrogen atoms. Depends on the number of hydrogen atoms that are there and number of carbon atoms, but it contains only hydrogen and carbon. All right, that is why we call them hydrocarbon. The main source of hydrocarbons is crude oil, also known as petroleum. So the chief source of hydrocarbons is where? Is what? Crude oil, or you call it petroleum. So that is the chief source, and we have defined what hydrocarbon is and the source of it, the chief source of it. Okay, hydrocarbons, the hydrocarbons are being classified into two because there are hundreds of different hydrocarbons on Earth, but they have been placed under two main classes. All right, they are aliphatic hydrocarbons and aromatic hydrocarbons. These are the two ways in which you can classify them, and under each classification, we can sub-classify it. All right, let's take a look at them. What is aliphatic hydrocarbon? What do we mean by that? Aliphatic hydrocarbons are those hydrocarbons that are open-chained. They are open-chained. Their carbon atoms form either straight chains or branch chains. Example of aliphatic hydrocarbons are the alkanes, the alkenes, and the alkynes. So these are the aliphatic hydrocarbons. Aliphatic hydrocarbons, they are straight chain, they could be straight chain, they could be branch chain, but they are aliphatic hydrocarbons. All right, and the next one is aromatic hydrocarbons. What do we mean by that? These are hydrocarbons whose carbon atoms form a ring, as if in a circle. They form a ring chain, and not only just a ring chain, but they are benzene and its derivative. It must have to have a benzene structure. They have close ring. They have ring, and it's not just anyhow ring, because we also have some close chain that are not aromatic hydrocarbon, but it must have to be benzene. So the main one is benzene and its derivatives. So example of what aromatic hydrocarbons are benzene, naphthalene, anthracene, and all of that. Anthracene and naphthalene, they are all benzene structure, benzene derivatives. Benzene structure of 2, benzene structure, 3 benzene structure, and other derivatives of benzene. All right, let's take a look at the chart that summarize the whole classification we have talked about. Look at it. Hydrocarbons are classified into aliphatic hydrocarbons and aromatic hydrocarbons. And the aliphatic hydrocarbon, they could be either acyclic, that means without ring, or they could also be cyclic. But what is important there is that you can also jump this one and classify from aliphatic hydrocarbon. We have alkanes, alkenes, and alkynes. You can see that the alkanes are saturated hydrocarbons. Alkenes, they are unsaturated. Alkanes are saturated. These alkenes and alkynes are unsaturated hydrocarbons. So this chart, this one supposed to be unsaturated. This is supposed to be unsaturated. These are unsaturated hydrocarbons. Unsaturated. Alkenes and alkynes are unsaturated, but alkanes are saturated hydrocarbons. So classification could be, just major classification are aliphatic and aromatic hydrocarbons. All right, let's take the family of alkanes. The first one, alkanes, the alkane family is a saturated hydrocarbons, as I just pointed out now, with the molecular formula of CnH2n plus 2. That is how to raise their membership. Number 1, number 2, first carbon atom, second carbon atom, third carbon atom, and all of that. So that is how to get their membership. And the first member is methane with this formula. The second one is ethane, third one propane, butane, pentane, hexane, heptane, octane, nonane, and decane, number 10. And these are their molecular formula that are being generated using this formula to get the molecular formula. So these are the general formula for the family, and their condensed form could be written this way. Then these are their structural formula of these formulas that we have. So this is for alkane family, and they are saturated hydrocarbon. Whenever you hear about saturated hydrocarbon, think alkanes, and any of these, any of them is a saturated hydrocarbon. Any of these member, any of these member of the alkanes. All right. Once again, their names are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. 10. These are at least the first 10 members. They are not only the members. From 11 upwards, we still have their names. But these are the basics that we need to know in this particular level. All right. The alkenes. What are the alkenes? Alkenes are the unsaturated hydrocarbon. You know, I said it before in that chart that it was a mistake. The alkenes, alkene family is an unsaturated hydrocarbon with the molecular formula of CN2N. So that is how to generate the general molecular formula to generate the family membership. But this one, the example follows this way, that first member of the alkene is 18, second carbon atom, which is 18, not methane. We don't have anything like methane because the double bond must exist between two carbon atoms. So these are double bonds. Alkenes are the double bonds, while alkanes are single bonded. So these are the membership. Second carbon atom, second number, carbon number is number 2, which are 18, propene, butene, heptene, pentene, hexene, heptene, and octene, nonane, and decene. And these are the structure of this particular family member. All right, let's take about the next one, which is alkyne. Alkyne family is also an unsaturated hydrocarbon, as I said before. They have triple bonds with the general molecular formula CN2N-2. These formulas, you need to know them and memorize them, because they are key to their membership, and even you knowing the particular formula that each name carries. All right, the first member of it also is ethyne, not methane. We don't have anything like methane because the triple bond must have to exist between two carbon atoms. See the triple bonds. So alkynes are the triple bonds, alkenes are two double bonds, while alkanes are single bonds between the carbon atoms. So these are propene, ethene, ethyne, propine, butane, and okay, this one is butane 2 or 2-butane. This is butane. So it depends on the particular one you are writing in terms of their nomenclatures. All right. Okay. Crude oil. What do we mean by that? When you talk about crude oil or petroleum, what do we mean? Crude oil is also known as petroleum, and it's been found in a huge underground deposits in many parts of the world. Crude oil is a mixture of what? Gaseous, liquid, and solid alkanes. So crude oils are alkanes, which are the saturated hydrocarbons. They are alkanes and aromatic hydrocarbons and other constituents. So so-called crude oil is a mixture of so many things on them: alkanes, alkenes, and aromatic hydrocarbons, and even other substituents. We also have impurities on it. Crude oil is not a compound, it's a mixture. Note it. And it occurs as a dark, sticky, and viscous liquid. So it's viscous, it's dark, and it's sticky. These are the things you need to understand. And of course, the word viscous, viscosity has to do with also with stick nature of it. All right, what do we mean by natural gas? Natural gas, also known as fossil gas, is a naturally occurring hydrocarbons gas mixture consisting primarily of methane, which is alkane, primarily of methane. It includes varying amount of other higher alkanes and some gases like nitrogen, carbon dioxide, sulfur dioxide, helium, etc. in small percentage. Of course, some of all these things are impurities on them, but natural gas is mainly of alkane, which most primarily is methane on it. Okay, we need to also understand that crude oil and natural gas are found from the remains of marine algae and the animals which gradually settle on seabed. Over the years, the remains become covered in mud and bacterial activities. Heat and pressure change the plant and animal remains into crude oil and natural gas. What we are just trying to say is that plants and animal die. And when they die, those in the sea and all of that, they after some times it's been covered with sand. Of course, current is flowing, it's covered with sand bed, and over many years and time, because of the heat and pressure and the heat, high heat and the bacterial activities there, they go down, and after some time they decay and turn into what we have as crude oil with millions of years. It's not what happened within 1 month, 1 year, or something like that. It's millions of years. All right, crude oil reserves. Do we have it in the country or do we have it in the world? Where are they? Crude oil reserves are found in many parts of the world, such as Nigeria, China, Indonesia, Saudi Arabia, Kuwait, Russia, United States of America, Canada, Venezuela, Australia, and even in Western Africa. So, or Western part of Africa, or West Africa. So, there are several parts of the world where we can see reserve of crude oil, where crude oil can be found. Of course, it's in Nigeria. And in Nigeria, crude oil is found in the Niger Delta areas and Calabar. From the oil drilling fields all over the North Nigeria, crude oil is pumped through pipelines to the oil terminals at Bonny, from where it is exported to the refineries at Port Harcourt, Warri, and Kaduna. And crude oil from Nigeria is described as light crude oil because it is sulfur-free. You see? And this makes the Nigerian crude oil to be in very high demand in the world market, unlike crude oil from Saudi Arabia and Venezuela, which have very high sulfur content. So because of that, Nigeria crude oil is highly has been in high demand because of sulfur-free, and we call it light crude oil. So crude oil is extracted by drilling very deep holes or wells into the ground using a rotatory ring supported by a crane. Okay, you need to understand that those things, crude oil, need to be refined. So refining of the crude oil, we call it crude because they have not been refined. Crude, the word crude means it's not refined. It has not been gotten in its usable state. So a large amount of crude oil, which is petroleum, is separated into several or various fractions in a refinery by a physical process of fractional distillation. very huge fractionating towers are used to carry out this process as follows. Now, it's been separated into several fractions, based on their boiling point in the physical states, in the physical process. And that is being done through what? Fractional distillation. And we use fractionating tower for that. Okay, now look at a diagram of a fractionating tower. We have it in fractional distillation. So look at it, and one is being heated. Crude oil, this is here, this is it here, and it enters through this particular place, in this particular tower. Then this is steam, and as it's being heated, the heavy oil will go out here based on their boiling point. The one that has highest least boiling point goes up as a gas, volatile gas. They go out here, gasoline out here, kerosene here, diesel here, and lubricating oil. Then the heaviest of them is oil, heavy oil. It goes out here. So they have been separated based on their boiling point, which is very, very important. And this fractionating columns is divided into several compartments by perforated plates called trays, and each tray contains a specific range of temperature in terms of their boiling point. As the vapor containing the mixture of the substance ascends the column, it cools, condenses, and being separated out into several fractions according to the volatility of the substance in the mixture in terms of their boiling point. Just the summary of it is that they are being separated out based on their boiling point. Okay, this means that the substance with low boiling points separate out first in the tray on the upper part of the column, while those with the higher boiling point is being separated later in the lower part of the column. All right, so what we have there, those separation there, we have this following principal fraction obtained from the fractional distillation of crude oil. These are the major things. One of them is gases, petroleum gases. These gases are liberated at the top of the column at a temperature of below 40 degrees. They are mainly hydrocarbons consisting of 1 to 4 carbon atoms. An example of such include methane, ethane, propane, and butane. These are the first 4 members of the alkane, and they are obtained there. What are their chemical importance to us? Chemical importance is that they are being used mainly as fuels for homes and industry. They are also used to manufacture products like hydrogen, ethane, carbon 4, sulfide, etc. So they are being used as fuel, both for homes and industries. All right, next one is petrol or gasoline. We have it there, is one of the fraction. And what does this one mean? It's a mixture of hydrocarbon consisting of 4 to 12 carbon atoms per molecule. It is a volatile liquid that distills over a temperature range of 40 to 200 degrees Celsius. Still remember that 1 to 4 are gases. From 4 to 12 now, they are liquid in nature. That means they exist in different states, and we have several members of them. Okay, their economic importance is that they are being used as fuel for motor vehicles, generators, aeroplane, and etc. And they're also good solvent for paint and greases. That is number 2. Number 3 is kerosene, is one of the fraction, and kerosene is faintly volatile liquid. Faintly is not very volatile. That contains hydrocarbon with 12 to 18 carbon atoms per molecule. It distills over in the temperature range of 200 degrees Celsius to 250 degrees Celsius. What is the economic importance of this? The economic importance of this is it is used as a fuel for lighting lamp and heating stoves at home. Of course, kerosene, we use them in our houses and cooking, and in every other things. It's also being used for driving tractors and some other modern jet engine. It is a good solvent for kerosene and also paint. So we use them for cooking, we use them for driving tractors, we use them for solvents, kerosene. All right, next one is diesel and gas oil. They are a mixture of hydrocarbons with 12 to 25 carbon atoms per molecule. They distill over in the temperature range of 250 degrees Celsius to 350. What is the economic importance? They are being used as fuel and diesel powered engine, like large power generating power plants. They are used for heating and they also serve as raw material for cracking process. The next one is lubricating oil, and they are heavy viscous, consisting of hydrocarbon with more than 20 carbon atoms per molecule. And what is the economic importance of that? Grease is used for lubricating moving part of engine and machine to prevent wear and tears. Last one is bitumen and other residues. They are solid residues left behind at the temperature above 500 degrees Celsius. Bitumen is used for surfacing roads and airfield. It means we use it in coal tar. We use it in our coal tar, and other residues are used in making protective paints, used in pipe coating and waterproofing roof. That is it. And for further discussion and inquiry, get to me through this contact, and remain blessed for being part of this video. Thank you and remain blessed.